So you're working in Cisco's ACI, and you've got this challenge, right? You need to steer specific traffic through, say, a firewall or a load balancer, but you can't just go blowing up your entire routing setup to do it. So how do you pull that off? Well, the answer is a really powerful feature called Policy-Based Redirect, or PBR for short. And in this explainer, we're going to break down exactly how to set it up and, maybe even more importantly, how to troubleshoot it when things go wrong. Okay, check this out, because this picture really tells the whole story. On the left, you've got your standard ACI traffic flow. Nice and simple, client straight to the server. But look at the right. With PBR, it's a completely different ballgame. We're actually grabbing that traffic mid-flight and detouring it through a firewall before it ever gets to its destination. That's the real power of PBR, surgically inserting services exactly where you need them. So let's break down how we actually make this magic happen.
Here's the game plan. First up, we're going to tackle the why, the core problem that PBR is designed to solve. Then we'll walk through the 4 essential configuration steps, from telling ACI about your device all the way to applying the final policy. And here's the best part. Stick with me, because in that last section, you're going to see how knowing these 4 steps inside and out basically gives you a built-in troubleshooting guide for free. Let's dive in.
All right, before we start clicking around in the interface, we really need to understand the fundamental concept here. You might be wondering, hey, ACI is a smart fabric, it knows how to route traffic. Why do I need to go through all this extra effort to set up a special policy? And the answer really gets to the heart of what makes PBR so useful. It's all about control. Here's the difference in a nutshell. Think of standard routing like following your GPS directions blindly. The forwarding table has a map, and it just sends packets along the most direct path, period. But PBR is like a traffic cop standing in the middle of the road. It sees your specific traffic coming and shouts, "Hold on, I don't care what your GPS says. For you and only you, I need you to take this detour over here." It's policy overriding the default path.
And this diagram just visualizes that perfectly. That green line? That's business as usual, just ACI doing its thing. But the red line, that's PBR in action. We've effectively drawn a new path on the map for traffic between our client and web endpoints, forcing it to take a pit stop through that firewall. And here's the really slick part. We did this without changing a single IP address or route on the endpoints themselves. That's the elegance of it.
So if you want to master PBR, and especially if you want to be able to fix it when it breaks, it all boils down to these 4 steps. They're a logical progression, each one building on the last. So let's walk through this playbook, starting right at the beginning with defining our service device.
Okay, section 2, and our very first configuration task, defining the device. And this makes perfect sense, right? Before we can tell ACI how to redirect traffic somewhere, we first have to tell it what that somewhere is. This step is all about making a formal introduction between our service device, our firewall, our load balancer, whatever it is, and the ACI fabric itself. So here we are in the APIC, and we're making some really critical choices right off the bat. Is your device physical or virtual? Simple enough, but more importantly, what's its function type? If you choose go-through, you're telling ACI this thing acts like a router. If you choose go-to, you're saying it's more like an invisible bump in the wire, a transparent L2 device. You have to get this right because the rest of your configuration totally depends on this definition.
On to section 3, creating the redirect policy. So at this point, ACI knows our firewall exists, but it doesn't have any instructions. It's just sitting there. This is the step where we write the actual orders. We create the core instruction set that says, hey, for certain traffic, here is the new next hop you need to use.
Now this screen, this is really the heart and soul of the whole PBR config. And I want you to focus your attention right down at the bottom where it says L3 destinations. This is it. This is where you punch in the IP address of your firewall's interface. That IP address becomes the new policy-defined next hop that overrides the normal routing table for any traffic this policy touches.
All right, section 4, building the service graph. Let's do a quick recap. We have our what, that's the device, and we have our how, that's the redirect policy. Now we need to actually draw the map. The service graph template is like a logical whiteboard where we get to visually lay out this new traffic path and connect all the dots.
Think of this as a drag-and-drop flowchart for your traffic. You literally pull your device, our firewall here, onto the canvas and drop it right in between the consumer and the provider. But, and this is huge, for PBR, there's one little checkbox on this page that is absolutely everything. See that route redirect box? You have got to make sure that's checked. If you miss this, the whole thing falls apart because this is what tells the graph to use our special policy instead of just routing normally.
And here we are, section 5, the final configuration step,
Applying the graph. We've designed the blueprint, we've drawn the map, now it's time to make it real. This is the moment we take our logical plan and actually deploy it into the fabric by attaching it to a contract between our source and destination EPGs.
This wizard is where it all comes together. It's pretty straightforward. We choose our consumer EPG, that's where the traffic is coming from. We choose our provider EPG, that's where it's trying to go. And then we link them with a contract, which is basically the rulebook that governs how they're allowed to talk to each other. It's this contract that's going to trigger our service graph.
And this is the final, critical piece of the puzzle. As you're setting this up, you'll get to the connector settings. I want you to notice that drop-down menu for the redirect policy. Ding, ding, ding. This is where you select that exact PBR policy we so carefully created back in Step 2. This is you explicitly telling the contractor, hey, whenever you see traffic that matches my rules, I want you to use this specific set of instructions to redirect it.
Okay, Section 6. Let's talk about the real world for a second. You followed all the steps, you click deploy, and nothing. Crickets. Traffic is getting dropped, or maybe it's just bypassing your firewall completely. Your first thought is probably, oh no, where do I even start? Well, here's the beautiful thing about this whole process. The best way to troubleshoot PBR is to simply walk back through the very steps we just covered.
Think of this as your personal troubleshooting checklist. You just go right down the list. Start at the top. Is the device defined correctly? Is it the right function type? Okay, check. Move to the policy. Did I have a typo in the next hop IP? It happens to the best of us. Next, the graph itself. Oh man, did I forget to check that critical route redirect box? Then check the application. Is this graph even on the right contract between the right EPGs? And finally, and trust me, this is a common one, did I actually remember to select my PBR policy in those connectors? If you can say yes to all of these, I can almost guarantee your PBR is going to work.
You know, the source material we're covering today has a quote that just absolutely nails it. It says that a PBR configuration is almost identical to a normal service graph. The only real difference is that you have to create and apply that layer 4 to 7 PBR policy. So if you already know how to do a service graph, you're like 90% of the way there. That policy is just the special ingredient, the secret sauce that makes the whole thing work.
So once you really get to hang a PBR, you unlock a much more flexible, much more dynamic way to insert services exactly where you need them, without being locked into the old ways of doing things with static routes. And that leaves you with a really powerful question to think about for your own network. Now that you have this tool in your toolbox, how is it going to change the way you architect your network for security and services?